All right, guys, welcome to episode 2. If you haven't already, please open the PDF that is in your Google your Google classroom. Sorry, I got distracted for a second. And make sure it's printed into a PDF so you can then bring it into Kami so you can write in it. In this lesson, we're going to be learning how to identify independent variables, dependent variables, and constants in an experiment. One of the first classes, not the first day of school, I'm probably not the second, maybe the third day of class. We're going to start off with a lab. And we're going to do lots of sort of experimenting through labs throughout the year. And when you design labs, you need to be able to identify the independent variable, the dependent variable, and important constants. So we're first going to define the variables and what they mean. And then we are going to look at some examples of experiments and identifying independent variables, dependent variables, and constants. So in an experiment, the independent variable is the variable, okay, that the experimenter is changing. So they are physically setting up the differences. Okay, so they are testing how whatever they're changing is they're actually determining what they are changing. And it's usually mentioned first in an experiment. Okay, the dependent variable is the variable, okay, that the person is measuring. So they don't change it themselves. It's the result of them changing the independent variable. And usually you'll see the words record, measured, recorded, written down. It's usually as a result of what they change in the beginning, they measure something else. And that is the dependent variable, as I zoom in for no reason. And then constants are other variables that must be kept the same for the experiment to be fair / valid. So like the example that I always give, if you owned a paper towel company, okay, and you made the claim that your paper towel absorbed the most water, one way you could cheat is when you put the water on the table, only give a little water on the table to the competitor paper towels and give yourselves a lot of water. So if you look at the bottom, if you scroll further down, there are some examples. We're going to do examples number 1 and number 2 together. And then you're going to do the last page by yourself. And then there is a quizzes assessment to take at the end. All right, so let's read this experiment. All right, so Alex wants to find out what toothpaste makes teeth the cleanest. Every day she brushes her teeth with a different product and then took a plaque test to see how much plaque was left. She used Crest, Colgate, Close-Up, and water. All right. So the independent variable in this experiment is what Alex is changing. So what is he setting up that's changing? And he's using a different brand of toothpaste. Don't just say toothpaste, because you could change a lot of things about the toothpaste. The amount, you want to be very specific about what he is changing. Now, the dependent variable is what exactly he is measuring. Yes, he's going to determine how clean the teeth are, but what is he measuring to determine that? He's determining how much plaque is left. So the dependent variable is what the person doing the experiment is measuring at the end of the experiment. And constants are every other thing that affects how clean your teeth would get, except for the brand of toothpaste. So the only thing you want to affect how clean your teeth get, or the people that are doing this, is the brand of toothpaste that's used. So some things that you might want to do the same is the amount of toothpaste, how long you brush, what else? The type of toothbrush, how you brush. So do you go up and down or side to side? Again, you could name constants forever. Usually you want to give at least 3. How teeth are brushed. I can't spell. All right. So again, we're going to do this last example together, and then you're going to try your best to do these. And again, if they're not perfect, we'll fix them when we get back to school in a couple of weeks. All right, so Darius wants to test how the mass of a paper airplane affected the distance it would fly. Paper clips were added for each test flight. As each paper clip was added, the plane was tested to determine how far it would fly. So if you think about what is the person changing, okay, what is the person setting up that they're changing? It's the mass of the paper airplane. You could say number of paper clips. I wouldn't necessarily think that's wrong, but they're changing the mass by adding paper clips. And what are they measuring? As we get our little text tool that's failing, they are measuring how far the plane flies. Okay, now constants, okay, are things that would affect how far the plane would fly besides its mass. We want to keep those things the same. So the material the plane is made, so it's paper airplane. So type of paper that they use, it is paper. The size of the plane, like it could be heavier, but we want it to be the I guess size. So shape is a better word. We want to, if they have two wings, they all should have two wings. Who throws it? So the force used to throw it. One thing that we're going force used to throw it. One thing we're going to see that really matters is like the amount of wind. So wind affects how things move. We're going to make sure when you're throwing each plane, the wind hasn't changed. All right. So following these as a model, okay, what I would like you to do is try to fill in these and then submit it to Google Classroom. And then there is a quizzes that has been linked to take that also test your ability. Like, again, it shows you the answers. It is timed, but you have 4 chances to do it. All right, guys, I will see you guys on the 29th.